So this discussion is regarding defining the maxima and the minima using the derivatives. This is actually a discussion that will help you when it comes to finding the maximum output or the minimum cost in the different market structure. This will help you in understanding further the lesson 1 and the lesson 2 of your um, midterm modular learning materials. Now, when we say maxima and minima, these are actually the plural when it comes to determining the maximum output, the maximum cost, minimum output, or the minimum cost. But usually, we do not have the minimum output, but we usually use it when it comes to finding the cost. So we usually use it when it comes to minimum cost, and the maxima is actually used when it comes to determining the output, but it does not mean that cannot be used when it comes to maximum output or maximum cost pala. Okay, so with this discussion, first is let's deal with what is a maximum or a minimum. Now, a maximum or a minimum could happen when the slope of a certain product, when a slope of a certain output or a certain function is considered to be the zero. Remember that in finding the slope of the function, we already have the basic formula, which is in using the calculus, the first derivative. Okay, the first derivative is always considered to be the slope of the function. Do not forget that. Okay, now finding the first derivative will now tell you if the slope would be higher, the slope would be lower, or if the slope is a positive or a negative itself. Yeah, and let's see, for example, how do we determine the use or finding the slope or finding the maximum or the minimum. Now, example, a business would like to reach an output anytime with a production function as follows. Now, a production function, this one, will now determine how much output is being produced with using the different variables or the fixed factors that we have. Remember that we have two kinds of factors, which are considered to be the variable factors and then the fixed factors. So by using these factors, how much output could be produced? This is the total product itself. Now, the V here will now represent the different variables. So I just put there as the variables itself. Now, depende which kind of variables are used when it comes to the production. It's either the labor or it's either the raw materials. Okay, so with this function itself, so what is the maximum total output? So remember, in finding the maximum total output, we always have to determine it using the derivative functions. Actually, in calculus, we have a lot of factors or functions that we could use, but in this, we are only using the basic one, which is the derivatives. Now, the derivatives will now be used also the Lagrange, or what we call this one, the partial derivatives itself. Okay, what is the maximum total output? Now, in determining the maximum total output, first, of course, is we have to determine the first derivative of the function, because as it is said here, the maximum or minimum could be derived every time the slope is considered to be zero. Kung saan i-equate natin siya sa zero para malaman natin if that considered to be maximum or minimum. So first thing is in deriving the derivative, first derivative, so finding the derivative of this function. Now, if we find the first derivative of this function, then here, it follows in here. Okay? Remember, class, that we always have to write the basic formula or the base formula itself. Now, the base formula of the derivative is always this one, which this d here all over dq will now determine or will now describes to us that we are finding the first derivative. And of course, on the other part of the function is we always have to deal it with this one if we do not like to write this one on the other side. So meaning if you write this one to the other side, then you have to write this one on the other side. But if you will write this f here on the other side and you do not like to write here, then you could use just the function f is equivalent to tp. Okay, so those are the other things that you could use when it comes to deriving your function is itself. So finding the first derivative is, of course, equate the function, always write the base formula. And if you will find the first derivative of this one is, we have this. So remember, this one will always have no values because wala siyang variables na indicated, wala siyang exponents also na indicated. So as usual, this one will now lead to a 0. Now the 14b to the first degree, that is 1 times the 14, remove the b, which is considered to be the 14 here. While the 5b squared, that is the 2 times the 5, which will become 10. And the q here, supposedly, that is supposed to be the v, or the variables. Okay? And then, of course, in here, we have already the value of the first derivative, which is this one. Okay, and the next one is find the slope. Okay, now find when the slope is equivalent to 0. That means we have to equate it to 0. Okay, we have to equate it to 0. So by equating it to 0, to the other side of the function is right. To the other side of the function here, write the 0 in here. Now after that, of course, transpose the functions. After transposing the functions, as we have here, b all over 14 10. So the b here is 1.4. Ibig sabihin, the slope is 0 if the variable or the output is equivalent to 1.4, meaning if the business uses a variable at 1.4 units, it will create a maximum output. Okay? Ganun po ang ibig sabihin ng finding the output and at the maximum. Now, you could actually use this on even if you have the total cost function or other kinds of functions itself, because these ones are still used no matter what. Even nasa different market structures tayo, pag meron tayong cost functions or meron tayong profit functions, you always deal with the first derivative. To find the slope, equate it to 0, always equate it to 0, and then finding the output in here. Okay, so that's how you do it when it comes to deriving. So therefore, since if we are going to use a 1.4 variables, how much is the maximum output then? So substitute it to the formula. So if you substitute it to the formula, you have this one. TP, or total product, is equivalent to 3 plus 4.5. 14 times 1.4 minus 5 times 1.4 to the second power. So the total product is 12.8 units. So with 1.4 variable units, you could actually produce a 12.8 units, which is considered to be the maximum output. Okay, so how do we know it is a maximum or a minimum? Now, you have to deal with the second derivative already. So the second derivative function will now determine if the function or if the output that we have derived here, if the output, which is the 12.8, is considered to be a maximum or a minimum. Okay, how do we determine if it is a maximum or a minimum? So if you're going to look at the graphical illustration, if the slope is considered to be the 0, that means the tangent imaginal line here will be the imaginal line here will be tangent to this curve itself, or what we call the total product curve itself. Okay, remember, when it comes to the slope, a rising portion will always be a positive and a declining portion will always become a negative itself. So meaning, if we determine if it is a maximum or a minimum, a slope that gets smaller, ibig sabihin, it goes through 0, not though, goes through 0, it means a maximum. If it is a larger one and it goes beyond the 0 already, then it is considered to be a minimum. So ibig sabihin, any number that is lower than 0 is considered to be negative 1. So if the value of the second derivative will give you a negative value, then it is considered to be a maximum. And sabi din dito, if it is minimum greater than 0, so anything that is positive will lead you at a minimum output, minimum cost, or minimum profit itself. Okay, so that's how you determine if it is a maximum or a minimum. So always deal with the greater than 0 or less than the 0 itself. Now let's deal with the second derivatives. Now in deriving the second derivatives, remember that you always have to get with the first derivative that you have found. So for example, when a function slope is 0 at x and the second derivative is less than 0, then it is considered to be a local maximum. If it is a greater than 0, then it is considered to be a local minimum. Pag equal to 0, then that means the test is considered to be a failure. That means the output that you have determined is neither correct or neither a maximum or neither a minimum. Mali po yun. So that means you have to go back. So, but if when it comes to going back to your functions and it's still the same, then that means the function is wrong. Okay, that means when it comes to managerial decision, you cannot decide already which one are you going to produce at a minimum or which one are you going to produce at a maximum. Okay, so that is the meaning of the failure of testing if it is equivalent to 0. Okay, now let's proceed to a mathematical example. So let's say y is a function of x with the function y is equivalent to 5x cubed plus 2x squared minus 3x. First, derive the first derivative. The first derivative here, of course, ito, y, the derivative of the function all over the x, wherein ibig sabihin, you are looking, parang binabawasan nyo ang value ng x para lang makuha nyo yung minimum part nito. Or para paliitin natin yung values, yung kasi ang ibig sabihin ng derivatives, hanggang sa makuha natin yung pinaka-zero niya. Para malaman natin if it is a maximum or a minimum. So once you derive the first derivative, here, the first derivative will now give you 15x squared plus 14x minus 3. Look at the result. Okay? Ang susunod natin gawin is we have to equate it to 0 to determine the value of the x. So in this case, if we are going to determine the value of the x here, then we have to use the quadratic functions. Okay? Now, by using the quadratic functions, now we have to equate it, and using the function itself, we could derive at the x two values of the x, which is considered to be the 3/5 and 1/3. So take note that in using the quadratic functions, you know already the functions. So I did not expand here what is the quadratic or how is the value of x was derived already here, because you know your quadratic functions. So if you're going to solve or use the quadratic functions, you will determine actually that the value of the output is, or the value of the x is this one. Now, once you find the value of the x, you get the second derivative of your first derivative functions. Now, by looking at or by finding the second derivative, you have to equate it to the second derivative, which is this one. The second derivative will be this. The second derivative of the function y, which is the 30x plus 4. Okay, so shortcut ko lang po siya, but if you're going to expand it, supposedly this one will give you this. Y squared d2 dx squared if you're going to expand this function here. Okay, so by means of that, you will have the final answer of the second derivative, which is the 30x plus 4. Now, how do we determine already if we have the maximum or the minimum? Now, substitute already the value of x here. We have 2x in here. Okay? So, if you're going to substitute it, and pag ang lumabas doon ay less than 0, you know already which one is the maximum and which one is the minimum. So, if you're going to substitute, for example, the 3/5 in the here, and it found out that we have a negative or a positive value, a positive value, then that means that is a minimum. But if we have a negative value, then that is considered to be a maximum. Okay? So, what are you going to do next? Here, substitute the value. So, at a negative 3/5, then you will have a less than 0. So, the value is, so the negative 3/5 is considered to be a local maximum because we have a negative value here if we're going to substitute the negative. Now, at a 1/3 output or at 1/3 x, substitute it, then we have a greater than 0 as a value. So, this is considered to be a local minimum. By looking at the graph itself, you could actually graphically illustrate it as this portion and at this portion. Okay? So you could already say that this one is considered to be the maximum and this one is considered to be your minimum. That's how you do it when it comes to finding the maxima and the minima. Okay? Now, remember that if you're looking at this one, it is considered to be the negative quadrant because negative 2. How come that it is considered to be a positive? Because that means, looking at the graph itself, this is the highest point. So you could say that this is the maximum. This is the lowest point. So you could say that this is already considered the minimum itself. Even at the negative portion, some other outputs or costs at the negative portion are considered to be the minimum or a maximum. Kaya nga sa business, hindi basta-basta tayo nagko-close ang business na biglang isasara natin to kasi may negative outputs tayo or negative cost. Kasi pag tayo biglang nagsasara ng mga businesses natin, the possibility mas malaki ang gagastusin natin. For example, your business is not already earning, bigla mong sinara. So, ang akala mo is makakatipid ka doon, hindi po. Kasi pag sinara mo ang business mo, ang mangyayari po doon, babayaran mo lahat ang separation fee ng mga empleyado mo, lahat ng mga iba't iba pang cost, kailangan mo pang bayaran yung mga interest, if you have interest when it comes to the capital that you use. So, remember that it doesn't mean that if you are already at the negative portion, you have to close your business. Okay, so by means of the graph itself, we could actually summarize or make a analysis that a high point is called the maximum, which is considered to be plural maxima, and the low point is considered to be the minimum. Why say local maximum? Because when there may be higher point elsewhere, but not nearby. We say local maximum when there may be higher point elsewhere but not nearby. So, dito, is you could say that this is a negative. Now, this is the lowest point. It is because wala naman pong ibang other curves that will tell us another negative portion. So, this one is still the negative area or the negative portion of the functions, or it is considered to be also your minimum point. Okay, so that is how to derive your own maximum and the minimum value. Now, let's proceed to considered to be some economic applications of this maximum and minima in terms of problem, because that is the mathematical illustration by using just the simple y and the x. Now, let's already use the proper terms in terms of the economic, where we use the price, the profit, the variables. We also use the labors, the wages, the interest. But I'll just give you a basic one. Now, take note, my dear students, na hindi porkat ito ang lagi kong pre-present, you are going to expect the same thing on your exercises, because the exercises will now give you another area of the application. Now, the application in our discussion will just be your basis. Because if I will give you the same problem as given on the discussion, then that means I'm not letting you learn from the discussion itself. Okay? So let's have a example. A game console manufacturer determines that in order to sell the X units, the price per unit must decrease by the demand function. Okay? Wherein the demand function is considered to be this one. Okay? Price as the function of quantity. Why is it considered to be a demand function? Akala ko po ba ang demand function is ganito? Quantity is considered to be the 100 minus 4p, wherein quantity is a function of price. Now, by looking at the formula itself in here, pwede naman po natin siyang i-interchange to become a price function. This is a quantity demand function. Now, pag ini-interchange natin siya to become a price function, the price will be at the other side and the quantity will be here, then it is still considered to be a demand function. So, a price function and a quantity demand function is also the same. But remember, what makes them different is the derivation already of the amount inside the function itself. Okay? Now, let's have this one. A price function is considered to be at this point. Okay? Price is a function of x, wherein 500 minus 0.1x per device. Okay? So, if you're going to translate this one to become a quantity demand function, pwede naman po. So, with the price which is considered to be 500 minus 0.1x, now, make it a x function. So this one is price minus 500 is equivalent to negative 0.1x. Okay? Hinahanap natin yung x function is considered to be the quantity. So you have to divide it with the negative 0.1. Okay, so 0.1 divided by the 0.1 is of course 1 or 0 pala. So it will become x. Okay, and then 1 divided by the 0.1 is considered to be how much is the value? Hanapin ko ang calculator ko. One divided by 0.1, that is 10. So that is negative 10p. Negative 500 divided by negative 0.1 is considered to be 5,000 plus 5,000. Pasensya na, hindi kasya. There, so we have here 10p plus negative 10p, sorry, plus 5,000 is equivalent to be the x, which is considered, the x here is considered to be your quantity. So this one, this function as a quantity demand function is also the same with this one. Okay, but since in the problem we have a price function, then we have to use the price function. At saka mas maganda din po gamitin natin ang price function because in deriving the total revenue, mas maganda po yung gamitin yung price as a multiplicative rather than the quantity. Okay, so the manufacturer also determines the cost depends on the volume of the production and includes a fixed part, which is the 100,000, and then the variable part, which is considered to be 100x. That is, of course, the total cost function already will give you this one, the total cost function. Total cost function from the very beginning is we have the fixed cost plus the variable cost. So that means the fixed cost here, which is considered to be this one, and then the variable cost will consider to be this one, 100x. Fixed cost is considered to be the 100,000. Okay, so what price? The question is what price per unit must be charged to get the maximum profit? So by means of that, you have to determine what is the first step that you're going to use. So the first step here is to find the total revenue. Remember, the total revenue function is considered to be this one. Okay, price times the x or price times the quantity. Now, total revenue is the price. Ano yung price? This one is the price here. We have the price here, so you have to put it there. Okay, times the x, which is this one. So by means of that, we have the total revenue already, which is considered to be 500x minus 0.1x squared. Okay, next thing, what is the next thing that you're going to do is to determine the profit function. What is the profit function? Here, the profit function is here yung tinatawag nating pi na yan in economics that is representing the profit. Okay? So, kasi po, pag ginamit po natin kasi ang total profit na TP, it will misunderstood the total product. That's why it is already used the symbol, the pi, as considered to be your profit. Okay? So, with this one already, substitute the TR and then the TC on the function. We have here the TR, which we had just solved here, the 500x. Plus minus 0.1x squared, and then the TC, which is this one, the TC. Okay, substitute it here to the formula, and we have here. Okay, again doing the longest part, we have already the profit function, which is the 0.x squared plus 400x minus 100,000. Remember, when it comes to arranging your own function, you always have to deal with the highest to the lowest or lowest to the highest. Hindi yung mix-mix na nauuna yung 400x, tapos biglang sa gitna is x squared, tapos biglang x cubed, tapos biglang 1,000. Hindi po. You always have to arrange it either from the highest value, highest exponent to the lowest, or to the lowest to the highest. Okay, so that's how you arrange them. Next, what is our third step? Third step, of course, is to find the first derivative of your profit function. For first derivative, so how do you derive it? The base formula of the first derivative. So always write this one. Do not just shortcut it, because sometimes if you shortcut it, I would say that you may copy it. Okay, so you have to deal with the process itself, just for me to determine if you really know how to do the process. Okay, so by means of that, deriving your own first derivative. So we have here the derivative of the 0.x squared. So we have the value which is considered to be the 0.2x, negative 0.2x plus 400. So of course this one will automatically become 0 because no polynomials or variable factors that are involved. So we do not deal with it. Ibig sabihin, regardless of we are going to find the maximum output or minimum cost, hindi na natin to papakialaman kasi it will always be included in the cost. Yun ang ibig sabihin yan. Kasi walang variables. It does not affect. So, ibig sabihin itong 100,000, kahit ganito ka mahal ang 100,000 na to, it will never affect your variables because it is not connected to it. Okay, so with this one, we have the first derivative. Once you find the first derivative is, what are you going to do next? Syempre, yung tanong kasi is what price per unit. Now, what price per unit? We have already the price function here. Ang dapat hanapin natin is the quantity, right? So that we could substitute the quantity here or the x here to find the price. So after this first derivative is, of course, find the x values. How are we going to find the x values? With the linear function already na meron tayo, then just equate it to 0. By equating it to 0, then we have already the function. So what is this here? Equated to 0. We have the 0.2x plus 400 to the 0. Of course, divide both sides. Transpose the 400 to the other side and then divide it by negative 0.2. So you have your x, which is the 2,000. Once you have here already the x amount, then you have to substitute it to the function. Substituting it to the function, as you will already determine the price. Okay? But first and foremost, we have to determine the second derivative to find the critical value or to classify the point itself. So what is the second derivative here? Now determine if the x is considered to be a maximum output or a minimum. Okay, so since p is negative or the price here, we have the second derivative is a 0.2, which is less than this one is supposedly 0. Okay, so sorry, this one is supposedly 0. If it is less than 0, automatically the x here is considered to be the maximum output. Okay, hence the profit is maximized when 2,000 game consoles are sold. So what is the price? If you're going to determine the price of the product, substitute it here. So the price here is considered to be 500 minus 0.1 times the 2,000. Okay, so we have here already 0.1 times 2,000 will give you 200. So 500 minus 200. So the price of the product is considered to be 300. Yeah, so we answered already the question. So what is the price that will maximize is at price 300, it will maximize an output which is equivalent to 2,000. Ganun po ang paggawa natin when it comes to a certain kind of application. Okay? Ganyan. So, remember to sum it up. And in economic application, the first order and second order conditions for functions of one independent variable will always be like this. Okay, the first order condition is this one, wherein the first derivative will equivalent to 0. The second order condition will always be this one. Remember the formulas. If it is considered to be a maximum, it must be less than 0. If it is considered to be minimum, it is equivalent to 0. Pag first order lang at gusto mong malaman ang maximum at minimum, you always just to equate it with your 0. Ganyan po when it comes to the first order and the second order. Now, on the second level example, let's have a second level example. That means, if we are already on the third or the cubic functions or even on the fourth level functions. Okay, another monopolist has a following total revenue and total cost functions. Total revenue is, we have already here the 45q, 0.5q squared, while the total cost is this one. 2 plus 57q minus 8q squared plus q cubed. Okay, question. Find the profit maximizing output level. That means maximizing. We are finding the put that will maximize the profit. So, nevertheless, we have to find the maximum. Hindi na natin papailaman si minimum. So, always equate it to the 0 to determine if that is maximum. Next is equate it to the second degree condition. Okay? There. So, the solution is, of course, first is determine the profit function. Second is the derivative function. I derive the first derivative. And then, of course, the third one is, of course, derive the quadratic functions kasi nasa cubic kayo, automatically ang labas niyan is magiging quadratic yan. Okay, so once you derive the quadratic, nakuha nyo na yung lahat, and then you find the x values. Okay? So with that, fourth one is to determine or to clarify if it is a maximum or a minimum by looking at the second derivative. Okay, so can you do that? So let's see. Let's do them slowly. Okay, so here is the function. Ang unang hanapin natin is the profit. So by means of the profit, I could use another pen which is very visible. Here, the profit is total revenue less total cost. So therefore, we have 45Q minus 0.5Q squared. Okay, less your total costs. 2 plus 57 Q minus 8 Q squared plus Q cubed. Pag ganito yung ginawa nyo when it comes to solving, there will be a possibility na you will just remove this parenthesis here and automatically copy that. Now, take note, always put the parenthesis on the second or every portion of it. Why? Because we have another sign at the middle. And this middle sign will have to be distributed to the different signs on the or between and among the functions itself. So, kasi pag ito nakalimutan nyo at itong parenthesis na to nakalimutan nyo, tendency is that etong mga signs, positive, negative signs na to ay magiging the same. And you will have a wrong answer already. So, do not forget and be very cautious when it comes to your signs. So, ang labas nito, this one negative here, if you're going to distribute it, it will become negative 2. This one will negative 57Q, positive 8Q squared, and then the negative Q cubed. So, if you're going to arrange it, you will have already a function which is considered to be negative Q cube. This one is considered to be Q 0.5 Q squared minus plus the 8Q squared. So, that means we have a 7.5 plus 7.5. Sorry, I could not write properly. 7.5 Q squared. Okay, next is the Q. This one here becomes negative. From the negative, if you're going to distribute it, it will become negative. So, therefore, that is negative 57Q. Positive naman yung isa sa kabila. So, the 57 plus the 45Q is considered to be 12Q. Okay, so that will become a negative 12Q already. Okay, with that, the negative 12Q, so next one is the last part, which is the lowest one, which is negative 2. Okay, so with this one, once already you have this one is considered to be your profit functions already. So just excuse me for a while. There, so if we have already the first derivative, Okay, the profit function, the next thing that you're going to do is to find the first derivative of the function. So finding the first derivative, of course, is already the d profit all over dq. Remember, class, since we are using the q, you have to use the q here. Once you use the x, I will mistake your answers. So be very cautious, okay? So in that case, you have to use here the f1, and then you copy the function, which is the negative q cube plus 7.5 q squared minus 12q minus 2. Okay, get the first derivative. So we have here the negative 3. 3 times the 1 here, that is negative 3. Q, 3 minus 1, that is the 2. Next, plus 7.5 here times the 2, which is the exponent. That will give you 15. Okay, Q, 2 minus 1 is considered to be 1, so that is considered to be Q. And then 12 here, Q to the first exponent, that is 1 times the 12, so that is automatically minus 12. And then the 2 here, which does not have any variable, will be automatically 0. Okay, here we have already the first derivative. So what is the next thing that you're going to do? The third step is to find the q value by using already your quadratic functions. So if you're going to use the quadratic functions, which is considered to be the q is equivalent to negative b plus minus, which is considered to be your b squared minus 4ac divided by 2a. 2a, okay? There. Yeah. So just substitute. Remember on the quadratic function, what is the quadratic function? That is ax squared plus bx squared plus c, right? So you know already your a and b and c, so you have to just distribute there. So 15x squared minus 4 times the a, which is the negative 3, times the c, which is considered to be the negative 12. We have 81. The square root of 81 is 9. What is the b? Which is 15. So positive 15 minus 9 is 6 divided by, of course, 2 times the a, which is the negative 6. That is 6 times the negative 6 will give you a negative 1. So the first x is considered to be negative 1. The second second quantity, sorry. We are using the q. Ako yung nagkamali. So the q1 here is considered to be the negative 1, where the q2 is, again, distribute the functions. So that is negative 15 minus 9 divided by negative 6 will give you positive 4. So that is the second. Okay, kasi yung una is negative 15 plus 9 divided by negative 6 is equivalent to positive 1. I'm sorry. So this one is still positive. Okay, so we have the two values already of your quantity, which is the quantity 1, which is equivalent to 1, and then the quantity 2, which is considered to be the 4. So you could use already this one to distribute to determine which one is the maximum or which one is the minimum. Maybe the 1 is considered to be the minimum or 4 is considered to be maximum, as it is already implicated here on the signs. But to make sure if these are the positive or the minimum is you do the second derivatives. Okay, so by doing the second derivatives is we have to erase everything here. The second derivative is by finding the second derivative, find the second derivative of the first derivative functions that you already have. So by using the second derivative here, look at this function here. This is the first derivative of the profit function. So if you're going to look at the second derivative, that is the D2 profit all over D2Q. Okay, so by means of that, let's just shortcut it. So the 2 as the exponent times the negative 3 will become negative 6. 2 minus 1, that is considered to be 1, so that is Q. And then, of course, this one, plus 15. Okay, so we have here the second derivative already. Now, by finding the second derivative, since we have two quantities already here, you have to substitute the two quantities to the functions. So, if you're going to substitute Q1 here, negative 6 times 1 is negative 6 plus 15 will now give you 9. Okay, positive 9, which is greater than 0. Next is the 4. Okay, so 4 times or multiply by the negative 6 will have negative 24 plus 15, and that is will give you a negative 9, and that is less than 0. Okay, negative 9, which is, sorry, that is not Q, less than 9. Ay, less than 0 pala. So that is the maximum. Here, so at quantity 4, we have the maximum output, and then at quantity 1, we have the maximum or minimum output. How about the minimum cost and the maximum cost? Okay? So, by means of that, eto naman. Pag gusto nating malaman yung minimum cost and the maximum cost, eto lang ang ating papakialaman. Hindi na natin papakialaman si total revenue at saka yung sa profit. Okay? Just make a derivatives on the total cost functions and just do this process, and then you will also find your maximum cost and your minimum cost itself. Okay, so that's how to determine your different kinds of maximum and minima. So I think that will help you when it comes to determining the different profits and the maximum profits, or even the revenues or the incomes, once you are already on the different market structures, which are considered to be the perfect market structure, the monopoly, monopolistic, and the oligopoly. But nevertheless, never even if you are already operating in a different kinds of market, you will always use the same kind of managerial decision, which is to maximize the profit and minimize the cost. And how are you going to do that? By using the calculus, which is considered to be the basic derivatives. Okay? Now, maglalagrange tayo or partial derivatives tayo pag we have already two variables that are involved. Dito sa lahat ng mga examples natin, we assume that labor is considered to be the variable and technology is considered to be the fixed. Okay, sa lahat ng mga applications natin. Now, we will go further sa ating partial derivatives pag nagamit na natin yon. Okay? So I think that is all for today, and I hope that this discussion helps you when it comes to determining your derivatives and the second derivatives already. So I will give you the next discussion sooner, and hope you have a good day. Thank you.